Imagine a symphony orchestra. Okay. Every single musician is incredibly talented. They've totally perfected their individual pieces, but they've never actually rehearsed together. Not once.
Right.
Now it's time for the big performance. What do you expect?
Chaos. Yeah, probably a mess.
Exactly. Chaos.
Right.
Precisely. And, the same principle applies, maybe even more critically, to the complex network of fire protection and life safety systems in a building.
How so?
Well, each smoke detector, each sprinkler, each fire door, they might be perfect on their own, individually tested, working fine. But for true safety, they absolutely need to perform as a harmonious, integrated unit. They've got to work together.
Like that orchestra finally playing in sync.
Exactly. They must sing in tune, not just individually, but as like a whole ensemble.
And that's exactly what we're diving into today, a deep dive into NFPA 4, the standard for integrated fire protection and life safety system testing.
This isn't just about, individual components working in isolation. It's about making sure every single part of a building safety system works together seamlessly as one unified system.
Yeah, and it's actually quite a story how this standard even came about. For a long time, this whole idea of integrated system testing, it was just a recommended practice.
Just a suggestion.
Pretty much. It was a chapter kind of tucked away within NFPA 3, which mostly dealt with commissioning systems. So, a good idea, people thought, but not something you had to do.
So what changed then? Was there like a big event or just a slow realization?
It was more a growing realization, I think. The technical committee saw there was this imminent need for something stricter.
The gap.
A serious gap. There were just too many cases popping up where individual systems, they pass their own tests fine, but when you put them all together in a real emergency scenario,
Yeah.
well, they just failed to communicate effectively. They didn't talk to each other properly.
That sounds dangerous.
It is. So that led to this critical decision. Back in 2011, they approved separating it out, giving it its own document, NFPA 4. And then in 2018, it officially became a mandatory standard.
Wow. Okay. So that's a huge shift from nice to have to must do.
Monumental, really. It means integrated testing is now a mandatory requirement, not just a friendly suggestion. It fundamentally changes the landscape of fire and life safety.
So our mission today is to really unpack what this critical shift means for fire and life safety. In the spaces you inhabit every single day, your office, your apartment building, everywhere.
That's the goal.
So if we stick with that symphony analogy, what exactly is NFPA 4 trying to orchestrate? What's its core purpose?
Okay, at its heart, NFPA 4 provides the definitive testing protocol. It's there to make sure that these integrated fire protection and life safety systems perform as intended.
As intended, meaning working together.
Precisely. It confirms the operation, interaction, and coordination of multiple individual systems. It's not enough for them just to be there. They have to collaborate flawlessly when things go wrong.
So it's like the ultimate dress rehearsal for a building's emergency response systems.
You could definitely say that, yeah.
And the focus is really squarely on that interconnection, right?
Absolutely. This standard applies to integrated passive systems. Things like fire-rated walls and doors that contain a fire and active systems like sprinklers and alarms that actively respond. It's specifically designed to test how all these different pieces communicate and interact.
Not just checking if the sprinkler head works on its own.
Exactly. It's about the chain reaction. Does the sprinkler activating correctly trigger the alarm? And does the alarm correctly trigger, say, elevator recall or smoke management systems?
Okay, so what doesn't it cover then? Is it replacing other tests?
No. And that's crucial. NFPA 4 does not cover the testing of the individual systems themselves. Those requirements are still handled by other specific standards, like NFPA 72 for fire alarms, or just the manufacturer's own instructions.
Ah, okay. So NFPA 4 kind of picks up where those leave off.
Precisely. It ensures the system of systems works in concert. It's the overlay.
That brings up an interesting point about the NFPA itself, the National Fire Protection Association. They developed these huge, detailed standards through a massive volunteer effort, right?
Thousands of volunteer hours from industry experts.
But they don't actually test things themselves or enforce the standards.
That's a really vital distinction. NFPA provides the rule book, the blueprint for safety that everyone agrees on. But the onus, the responsibility, is entirely on the users, building owners, facility managers, contractors, and the local authorities, the AHJs, to implement and enforce it.
So NFPA writes the music, but someone else has to make sure the orchestra plays it right.
Great analogy, yes. It's a testament to self-regulation within the industry, but it also means the responsibility for actually applying it correctly falls squarely on those using the standard.
And these standards aren't set in stone, right? They change.
Oh, absolutely. They're living documents. They can be updated through things called tentative interim amendments or TIAs, or corrected by errata if errors are found.
So if you're using NFPA 4,
You have to check the NFPA website, nfpa.org.dosinfo. Make sure you have the absolute current version, including any of those amendments or errata. It's constantly evolving to keep up with new tech and lessons learned.
okay, super important. So we've talked about the what the standard is. Now let's shift to the who. Who exactly is behind this complex testing process? Who's conducting this safety symphony?
Right. Well, if you look at the big picture, the building owner or the system owner, they bear the ultimate responsibility.
The buck stops with them.
Pretty much. It's their building, their system. Now, they are allowed to delegate this responsibility. They can pass it off to another person or organization. But there has to be a written delegation. It needs to be formally documented, usually as part of the overall test plan we'll talk about. You can't just verbally hand it off.
Makes sense. Accountability. So who actually does the testing?
Okay. To actually perform the tests, an integrated system test team must be established. That's the formal term.
A whole team.
Yes. And at a minimum, this team includes two key roles: the integrated testing agent, usually called the IT, and then the installation, testing, or maintenance people for each separate system that's being integrated.
So the fire alarm tech, the sprinkler tech, the elevator tech.
Exactly. Whoever is responsible for each piece of the puzzle needs to be part of that team, though it's flexible too. On similar projects, the standard says the owner or their representative can actually take on the IT role themselves.
Okay, so it scales a bit. But let's focus on that ITEA, the integrated testing agent. That sounds like a crucial role. The maestro, maybe?
That's a great way to put it. The IT is identified by the owner, and they are responsible for, well, pretty much everything: planning, scheduling, documenting, coordinating, and implementing the integrated system testing.
Wow, that's a huge job. It's not just ticking boxes.
Not at all. It's the strategic linchpin. This person or company is the conductor, ensuring that all this expensive safety equipment actually works together when seconds count.
So what kind of qualifications does the ITA need?
They need to have demonstrated skills, experience, or knowledge related to the design, installation, operation, and maintenance of the specific type of fire protection and life safety systems that are installed in that building.
So they need to understand how these different systems are supposed to work together.
Precisely. It's not necessarily about knowing every single wire in the fire alarm panel, but understanding the overall integration, the sequence of operations, and where potential failures might occur in that interaction.
So it really emphasizes collective expertise then. The ITA leads, but the whole team needs to be knowledgeable.
Exactly. The standard says the entire integrated system test team needs a working knowledge of the integration between systems that they're testing.
It's not about one person being a superhero who knows everything.
No, it's about ensuring the combined knowledge on that team covers all the complex interactions and potential pitfalls, which, raises an important question for you listening. Who in your building or the buildings you go into often fulfills these critical roles? Is there an identified ITA? Is there a team that's worth thinking about?
Definitely. Okay, so we know what NFPA 4 is. We know who's responsible. Now let's explore the how. How does this complex process actually get done on the ground? What's the roadmap?
Well, it all starts with a really detailed blueprint. The integrated test plan. For any new integrated systems, having a comprehensive test plan is like the absolute minimum requirement.
The score for the orchestra.
Exactly. This document is the step-by-step guide for how the integrated testing is going to proceed. Without it, you're just winging it, which is not what you want with life safety systems.
I imagine that plan has to be incredibly thorough. What goes into it?
Oh yeah, it's detailed. It needs written verification that the systems were actually installed according to the design documents, first off. Then a list of all the individual systems that are going to be tested. Identification of the entire integrated test team we just talked about.
Okay, the basics.
Right. But then, crucially, it must contain a comprehensive functional matrix, sometimes called a sequence of operation.
What's that exactly?
Think of it like the detailed script. It shows all the possible system inputs, like a smoke detector activating, and then lists all the associated output functions that should happen because of that input.
So like input smoke detector floor 5, output alarm sounds floor 5, elevators are called to lobby, smoke dampers close floor 5. That level of detail.
Precisely that level. It's the exact choreography of the emergency response. The plan also needs necessary drawings, like riser diagrams, control diagrams, visual aids, a narrative description explaining the specific test scenarios they'll run, and of course the test schedule, including how often periodic tests need to happen.
Okay, those test scenarios sound key. Simulating the crisis, right?
Exactly. They're designed to demonstrate that the final, installed integrated system complies with the design goals and the codes. And these scenarios must include specific events, like simulating a loss of normal power to see what happens,
What else?
simulating water flow from a sprinkler system, or the presence of smoke-activating detectors. Now, for periodic testing later on, you are allowed to use simulated events to trigger the initiating devices.
So you don't actually have to, like, start a small fire or flood the place every year?
Thankfully, no. Simulated inputs are fine for routine checks, but the system has to react as if it were real.
And the standard insists on testing the whole chain.
Very clearly, it states, end-to-end testing shall be required. That means testing the full sequence, from the initial input, that smoke detector going off, all the way through every intermediate step to the final intended output, elevators recalling, doors releasing, smoke control starting up, maybe a suppression system discharging.
So verifying the entire pathway, not just bits and pieces.
The whole critical pathway. No skipping steps, no assuming connections work. You test it all.
Okay, so this really robust test plan is mandatory for new systems. But what about, say, existing buildings? Or buildings with simpler systems? Does every single building need this huge, complex plan document?
That's a great question, and the standard actually has some nuance there. It does acknowledge that an integrated systems test plan, the document itself, shall not be required for buildings with limited integrated systems.
Ah, okay. So some buildings are exempt.
Whoa, careful there. Exempt from the plan document, maybe?
Okay.
But, and this is the really critical part, even if a detailed written plan isn't required, integrated system testing is still required.
Okay, that's a huge distinction. So you still have to do the testing. You just might not need the formal plan document if it's simple enough.
Exactly. You can't skip the testing just because you didn't need the big plan.
Can you give us an example of limited integration where maybe a plan document isn't needed?
Sure. Think of maybe a smaller building. It only has a basic sprinkler system, a fire alarm system that monitors the sprinklers, and maybe elevators that recall an alarm.
Pretty standard stuff.
Right. The integration points there, like water flow activating the fire alarm, or a lobby smoke detector recalling the elevator, those connections are often already tested as part of the individual system testing required by other standards, like NFPA 72 for the fire alarm.
Ah, so the integration points get covered during the routine fire alarm or sprinkler tests anyway.
Often, yes. So
Yeah.
in that case, NFPA 4 says you might not need a separate dedicated integrated test plan document on top of that, but the integration itself still absolutely gets verified.
Okay. But then a more complex building, say a high-rise.
Oh, absolutely requires a plan. Imagine a high-rise with sprinklers, fire alarm, elevators, plus maybe a complex stair pressurization system for smoke control, and automatic closing fire-rated doors tied in, and maybe advanced HVAC smoke control sequences.
Way more interactions.
Exactly. The intricate interactions between all those systems, they absolutely demand a formal, detailed, integrated test plan. The more complex the system gets, the more potential points of failure there are in the integration. So the more vital that plan document becomes. You need that detailed script.
Right. The potential for one system interfering with another just multiplies. Okay, so you have your plan, or you know what needs testing even without a formal plan. It's time to actually do the tests. What's the first priority?
Safety. Always. Before any integrated tests even begin, the risks involved in the testing itself must be assessed. That happens during the development of the test plan, or just before testing if no plan was required.
Assessing the risks of the test. Why?
Because the tests themselves cannot endanger anyone. Not the building occupants, not the personnel doing the test, not the building itself or its contents or its normal operations. You can't cause an emergency while testing for one.
Makes perfect sense. Who's responsible for that risk assessment?
The ITA, the Integrated Testing Agent, is responsible for making sure that assessment is done and documented. Safety first, always.
So during the actual integrated testing, what functions need to be checked? Is it just the fire alarm and sprinklers?
Oh no, it's comprehensive. All required building functions that are part of the integrated system must be verified. That includes, yes, sprinkler system alarms, but also egress lighting activation, smoke control systems, elevator control and recall, fire alarm signaling, both internal and maybe to the fire department, fire pump operation, potentially security system interactions like door unlocking, HVAC controls shutting down or going into smoke mode, and any special suppression systems.
Wow. Okay. It's really touching almost every major building system that plays a role in an emergency.
If it's integrated for life safety, it needs to be part of the integrated test. Leave no stone unturned.
What about retesting? What if something fails during the test or they have to make a change?
Good question. The standard says testing must be repeated if any changes or corrections are made to systems during the testing process that could affect their overall functionality. You fix something, you test again.
The whole test.
Not necessarily the entire thing from scratch. This is where it gets interesting. Let's say an individual system component fails, like the main fire alarm panel has an issue during the integrated test.
Okay.
That individual system, the fire alarm panel, is allowed to be repaired and then retested without necessarily triggering a complete new integrated test of all the other systems again.
That sounds practical. Avoids massive disruption if just one part hiccups.
It is practical, but, and this is key, you do have to retest the specific integrated functions that were affected by that failure or the repair.
So you test the connections again, make sure the fix didn't break something else in the interaction.
Exactly. You have to confirm that specific part of the symphony is back in harmony after the repair. And, related to changes, the standard is also quite clever about catching unintended consequences.
How so?
Let's say you modify one part of an integrated system. Maybe you upgrade the software for the smoke control system. Obviously, you test the known changes. But NFPA 4 also requires testing a sample of the unaffected input functions of systems that were changed.
Wait, testing things that weren't supposed to be affected. Why?
To catch those hidden domino effects, it requires testing typically 10% up to a maximum of 50 devices of the inputs that shouldn't have been affected by the change on each integrated system that was modified.
So it's like a random spot check to make sure your software update for smoke control didn't accidentally stop the elevators from recalling correctly.
Precisely. It's a safeguard against those subtle, potentially catastrophic ripple effects that you might not expect, making sure a seemingly small tweak doesn't disrupt other critical functions.
That's a really smart proactive failure finding. Okay, so when does all this rigorous testing actually happen? What are the main frequencies?
Right, there are basically three main triggers. First, there's the initial integrating systems test. That happens when the system is first installed.
During construction?
Typically, yeah. Usually done during the construction or commissioning phase, definitely before the building gets its certificate of occupancy. You want proof it works before people move in.
Makes sense. What's next?
Then you have periodic testing. These integrated systems require ongoing periodic tests to make sure they stay functional. The frequency is usually specified in that test plan we talked about.
And what if it's an older existing system that never had a test plan or an initial NFPA 4 test because the standard is newer?
Good point. For those existing systems, an integrated system test plan must be developed within 5 years of the standard being adopted by the local jurisdiction. And the first periodic test needs to be performed within 5 years as well, unless the plan itself allows for a different frequency based on risk or system type. It's about bringing older buildings up to speed.
Okay, so initial, periodic. What's the third trigger?
It's trigger-based testing. This means integrated testing is also required whenever certain events occur.
Like what?
Like when new fire protection or life safety systems are installed and connected into existing ones, or when existing systems are modified to become part of interconnected systems. Or, and this is really important today, when changes are made to the site-specific software for an individual system that's part of that integrated network.
So anytime you significantly change the setup or the programming.
You have to re-verify the integration. Anytime you potentially mess with the harmony, you need to run checks to make sure the whole piece still works together correctly.
Okay, that covers the who, what, how, and when. The final piece seems to be the paper trail. Documentation and record keeping. Why is that so important?
Oh, it's absolutely critical. All this rigorous testing. Well, it means a lot less if there's no record of it. Upon completion of the testing, the ITA has to submit a final comprehensive report to the owner.
What's in that report?
It summarizes all the test results. And it includes either a narrative description or maybe that functional matrix again, but this time showing the results describing each test scenario that was run and the actual response of every integrated and individual system involved. Did it pass? Did it fail? How did it perform?
A complete history of the performance.
Exactly. And if any test result doesn't comply with the design intent, if something failed, a detailed description of that fault has to be recorded in an issues log. And for every single non-compliance found, a separate corrective action report must be prepared.
What does that entail?
It provides specific details of what went wrong, and importantly, what was done to fix it, the remediation. This isn't just, bureaucratic busy work. It ensures there's a clear path to resolution, assigns accountability, and prevents problems from just getting ignored or forgotten.
Creates a clear record of problems found and problems solved.
Precisely. And this documentation needs to be kept safe. The property or building owner is the one responsible for record retention.
For how long?
The initial integrated system test documentation, that very first report, must be retained basically for the life of the system, or at least until a completely new initial report is generated, like after a massive overhaul. For the periodic tests, the standard typically requires keeping the two most recent reports or test documents.
Yeah, you always have a recent history.
Right. And all these records, they have to be kept together in one specific location in the building. And that location should be clearly identified, usually right at the main fire alarm control unit, so anyone who needs it, maintenance, inspectors, fire department, knows exactly where to find it.
That makes sense. Easy access.
This whole rigorous documentation process ensures that the history of your building's safety systems is preserved. It provides a clear record for future maintenance, for planning modifications, and of course, for authorities to verify compliance. It reinforces that ongoing commitment to safety.
It's like the building's safety diary, the institutional memory of its life-saving systems.
That's a good way to think about it, yeah.
So we've really unpacked NFPA 4 today, and it's clear it's far more than just some dry technical standard, isn't it?
Absolutely. It's a comprehensive, living framework. It's designed to ensure that these incredibly complex, interconnected systems that we rely on to protect lives and property, that they function seamlessly as a whole, from the moment they're installed right through their entire operational life.
It's about taking all those individual, potentially very good parts and making absolutely sure they perform that perfectly coordinated safety ballet during an emergency every single time. It's about moving beyond just individual readiness to proving true collaborative performance under the worst-case conditions. A really fundamental shift in thinking about building safety. So the final thought for you, our listener. What does this all mean for you? Knowing the sheer complexity involved, the detailed requirements of integrated system testing under NFPA 4, how might understanding these standards change the way you think about or maybe even engage with the safety features in the buildings you use every day? Whether that's your office, a hospital you visit, or the high-rise apartment you live in.
Something to definitely think about next time you walk into a large building and see those sprinklers and detectors. There's a whole system, hopefully tested, working behind the scenes,